There are properties of carbon that makes the study of carbon compound so difficult, and due to that reasons, there are so many or numerous organic compounds. These numerous organic compounds are based on the property of carbon. Carbon is one element out of the elements you can preview, element you can see in the periodic table. Carbon is so unique on most elements in that group where carbon belongs. Like carbon in the periodic table belongs to group 4, and most elements, including carbon in that group, are so unique. Their uniqueness is based on the fact that carbon can form large or numerous compounds. And this gives the reason why organic compounds are so numerous. Okay, now if you look at that group 4 elements, carbon is the first element in group 4 belonging to period 2, group 4, having 4 valence electrons. And silicon follows suit. Silicon is also a member of group 4, but belonging to period 3. So if you compare the size of the atom, recall that size of the atom going across the period is getting smaller, but going down the group is getting bigger. So size of atom increases down the group. So what account why carbon being in the same group with silicon, carbon tend to have so many compounds, so numerous compounds than silicon, is because the size of carbon gives it that advantage to form large or so many compounds, too numerous compounds. So I'm going to be looking at the properties of carbon that gives it that ability to form numerous compounds. One of the properties that gives that carbon that advantage above any other element is catenation ability. Catenation. That is the ability to catenate. Catenation. This term catenation simply means chain making. This is one property of carbon that gives it that ability to form numerous compounds. Catenation. What is catenation in a sense? Catenation is the ability of carbon to make bond with itself. And then this bond can either be in a long continuous chain, branch, or ring. I'll define it quickly as this is the ability of carbon to make or form bond or link with itself in a long continuous or branched or ring chain. That is catenation. Okay, like I did say, in a short form you can call this chain making. Ability of carbon to make chain. Now, the reason why carbon in that group can make chain with itself, like I said before earlier, just now, that carbon has small size. The atomic size of carbon is small, based on the fact that in the periodic table, carbon is in period 2. So if you're going from that periodic table from left to right, the size of atom decreases. So that is giving carbon that advantage to have small size and giving that advantage to be able to make bond with itself. Look at how the bonds is shown. Carbon is one element that can form a bond with itself. It doesn't stop here. The bond may continue up to infinity. I say up to infinity. This chain is straight, so I can call it long or straight chain. Long or straight chain. Okay, apart from this, carbon can also form branch. What do I mean by that? A chain may continue at a point, it starts to what? Form a branch. Carbon can form branch as well. This is also catenation. Again, ring chain. Carbon can decide to form a cyclic form of chain, whereby the carbon appears to be in a ring form. So this concept here is called catenation. This is one property of carbon that gives it that ability to form numerous compounds. And that's why organic compounds are so many or so numerous, because of one reason of carbon, one element that can form bond with itself. And under that, we discuss it under the property called catenation. Okay, and then the second property that gives carbon that advantage to have too many compounds is ability to form bonds with other elements. Another property that gives it that numerous compound is ability to form bond with other elements. There are elements that carbon is also affinitized to be able to form bonds. It has also affinity to form bond with those elements. And those elements can be hydrogen, oxygen, nitrogen, halogens. Halogens such as fluorine, chlorine, bromine, and then iodine. And last but not the least, metals. So this can account why the compounds of carbon is so numerous based on the property of carbon, which is ability to form bond easily with other elements. Can form bond with hydrogen, as in hydrocarbon, can form bond with oxygen, can form bond with nitrogen, can form bond with halogens, it can also form bond with metals. Example, Grignard reagents is a bond between magnesium and a long chain alkyl group. Okay, this is another reason, another property that gives carbon that ability to form numerous compounds. And then the next property that gives carbon that property, that ability to form numerous compound, is the ability to form multiple bonds. That's number 3. Ability to form multiple bond. So viewers, apart from single bond, carbon is one element that can form carbon-carbon double bond and also carbon-carbon triple bonds. Okay, it can form carbon-carbon double bond and carbon-carbon triple bond. These carbon-carbon double and triple bonds are called unsaturated compounds. Apart from single bond, carbon can form a multiple bond. Then the last property of carbon that gives it that ability to be too many is isomerization. Isomerization. This is the ability of carbon to exist in 2 or more. This is the ability. Okay, this is the ability of carbon to exist in 2 or more forms or compound having the same molecular formula but different structural formula. This is one property of carbon that gives it that advantage to other elements. Okay, now a hydrocarbon with molecular formula C5H10 may appear to have 3 different compounds. Just an organic compound with this formula, they appear to have 3 different compounds. 1, 2, 3. One can be normal pentane, that is straight chain alkane. 2 is 2-methyl butane. This is still a compound with this formula. And then the last one is 2,2-dimethyl propane. So the concepts where an organic compound may exist in two, this is three now, in two or more form or compound having the same molecular formula, but the structure of normal pentane differs from structure of 2-methylbutane, as structure of 2,2-methylbutane differ from the both. So this phenomenal occurrence is called isomerism, or you can refer to it as isomerization. So this is the ability of carbon to exist in two or more forms having the same molecular formula. Okay. So these are the properties, list of the properties of carbon that gives it that ability to form numerous compounds. One is catenation. Two is the ability to form bond with other elements. Three is the ability to form multiple bonds. And then the last is isomerization. Based on the ability of carbon to catenate or form bond with other elements, or form multiple bond, or isomerize, lead to the formation of too many compounds.